All right, everyone. Welcome to our next unit here. Our next unit is on elements, compounds, and mixtures. This is our next piece that we are going to start to discuss. Our main ideas, the things I'm hoping to have you get from this is number one, I can use properties to classify compounds, mixtures, and elements. So I would like for you to understand the difference between a mixture, what is a compound, and what are some elements, the idea behind them. They're very different concepts. I want you to understand what a compound is, what a mixture is, and what an element is. In today's lesson, we're going to talk about, I want you to be able to classify what metals, nonmetals, and metalloids are based on their properties, what properties make them metals, what properties make them nonmetals, and what properties make them metalloids. And the last thing is that I can describe three properties that makes up a mixture. We're going to spend a lesson talking about what is a mixture and what are three properties of those things that make that a mixture. We're going to move a little faster in this unit. I would like to get this unit done before Christmas. So keep up with me. I'll be doing lessons like this via the internet. We'll be going through each one of these packets, each one of the sections together. So please follow along with me as we go through those. All right, good luck. All right, to start our unit, our chapter, we are going to talk about why did the Titanic sink? Now, I'm sure a lot of you know what the Titanic is. I'm sure you understand why the Titanic sank is because it hit an iceberg. I don't know if you've ever seen the movie, they go, iceberg right ahead. Okay, this is why some scientists think that the Titanic sank. If you read this passage, I'll read it with you, and we'll talk about why we think the Titanic sunk. This really happened in the early morning hours of April 15th, 1912. The Titanic, the largest ship ever to set sail, sank on its first voyage. The Titanic was considered to be unsinkable, yet more than 1,500 of its passengers and crew were killed when it hit an iceberg and sank. Iceberg right ahead. Now, how can an iceberg, which is made of ice, destroy the 2.5 centimeter steel thick plates that made up the Titanic's hull? Analysts of the recovered piece of the Titanic's hull showed that the steel contained large amounts of the element called sulfur, which is a normal component of steel. However, in this case, the steel contained much more sulfur than the standard for steel made today. So if you talk about, sometimes you hear about, I think Donald Trump talked about how China was flooding the United States with bad steel. This is a good example of it. It's not pure steel. It's a different type of steel. It's not as strong as the typical steel that Donald Trump was saying that we were making in the United States. The excess sulfur may have caused the steel to be brittle, much like glass. Scientists suspect that the brittle steel may have cracked on the impact of the iceberg, allowing water to enter the hull. Could something as simple as using less sulfur in the Titanic's steel have prevented the ship from sinking? We may never know. What is known, however, is that the composition of the compounds and the mixtures is very important in preventing future disasters. A good example is this: is my wedding ring is gold, but it's not pure gold. There's other metals in there that make it a little bit different. So it's not pure gold, kind of like the steel. The steel is made, if it wasn't made correctly, it would have been a little bit more brittle. All right. So that is why the Titanic ship sunk. So now you can tell your parents, I know why the Titanic ship sunk. All right, let's continue. Our first section today is section 1, talking about elements. Today I want to talk about what is an element, how do elements differ from materials, and how are elements classified. We can classify elements into 3 different types, and we're going to talk about that. I'm going to read through this. I will stop a little bit, kind of go over the reading checks. I am not going to write the reading check in there, but you will be able to see, we'll talk about the reading check, so you'll be able to write those things in there so you won't just have a blank sheet. So that at the end of our lesson today, you should have those spots done. Those reading checks and things should be done. All right, so I'll start reading. You guys can follow along with me. All right, what are elements? Many materials can be broken down into simple materials. For example, some rocks contain copper. When they are heated in a large furnace, the copper separates from the rest of the rock. Another example is breaking down water by passing electricity through it. The electrical current causes hydrogen gas and oxygen gas to form. And I talked about this in school. We were talking about just like the difference between a gas and a liquid, how we can pass electrical current through water and it could separate those two things. So we can separate hydrogen and oxygen into two separate elements. At one point in time, they were trying to tell us that you could run your car off of water. You just put water in your gas tank, but then you'd have to have a strong electrical current. It would separate those two. It would release the oxygen out, and then you would be able to use the hydrogen to power your car. You don't see that as much anymore, but that was an idea for a while. Continuing here, some materials cannot be broken down or separated into other materials. An element is a pure substance that cannot be broken into simpler substance by chemical or physical methods. So that's like our water. When we take our hydrogen and our oxygen, those are elements. They can't be broken down any more than that. Those are the basic building blocks of everything that we see. Everything that we see, if I have like this pop bottle here, this is broken down. If I were to break these down into the elements, you'd have all these different things, okay? And they make up this pop bottle. This is how elements are different from all other materials. Okay, the second thing we're going to talk about is a pure substance. A pure substance is a material in which all of the basic particles are the same. For example, table salt contains particles from sodium chloride. Table salt from anywhere is the same. All pure substances, except for elements, can be broken down into simpler substances. So let's go look at our reading check here. Our reading check says compare. How does an element differ from a pure substance? Well, pure substances can be a combination of elements. So those pure substances can be broken down into the elements. Whereas your elements, they can't be broken down into pure substance. I mean, that's the lowest it can go. Do you understand what I mean by that? So like a pure substance, we could have just oxygen. Okay, and just hydrogen. We can also have a pure substance of water and only water, okay, water. But we could break that water down into elements, which is oxygen and hydrogen, but we can't break down oxygen and hydrogen anymore. The basic particles of an element are called atoms. Copper is an example of an element. All of the atoms in a piece of copper are alike, as shown in the figure below. Iron is an element. We take a look at this picture here. We have this dude. He's eating something. He's got a spoon here. He's got this rock here. All of those things are iron. Okay, they're all different types, but they're all iron. The iron atoms in the meteorite from space are the same as the iron atoms as the iron atoms in the steel spoon. There are also iron atoms in the cereal that in the boy's braces and in his blood. So we can find iron all over, okay? If we look at question number 2, take a look. It says, look at the illustration and identify one source of iron that comes to Earth from somewhere else. It could be from steel. It could be from food. It could be from rocks. It could be any of those things, okay? It could be any of those things. All right, the next piece we're going to talk about is how can irons be classified? Okay, elements can be classified based on their properties. There are 2 different types of properties. We've talked about this, chemical properties and physical properties. Physical properties include hardness, melting point, density, malleability, thermal conductivity, all those things we talked about in our last unit. Chemical properties include reactivity, flammability, and a lot of other things. We can use properties to tell elements apart. For example, the elements helium and krypton are both colorless, odorless, unreactive gases. However, the elements have very different densities. Remember, our density is mass divided by volume. Helium is less dense than air. So helium will float. It just floats up. We know that. It makes our voice really, really high. And krypton is more dense than air. Krypton-filled balloon, on the other hand, will sink to the floor. I mean, I've never sucked up krypton. I don't know if it makes your voice really low. But I don't know. Okay? I'm not sure. If we look over here, it says, what are 5 physical properties that are characteristics of an element? Well, 5 physical properties would be hardness, melting point, density. We have reactivity, flammability. Those are chemical properties. We have colorless, odorless. Those are also physical properties. Those are 5 physical properties that can classify an element. If we take a look at three elements that are very, very similar, we have cobalt, we have iron, and we have nickel. They're all metals. They all look the same. They're all shiny, but they are 3 different types. They have 3 different things to them. If you take a look at this, you see the melting point is 1,495 degrees Celsius for cobalt, 1,535 for iron, and 1,455 for nickel. So they're all different. We could melt them at all different spots. We see that the density between nickel and cobalt are the same, whereas the density for iron is less. Okay, conductivity, they all conduct the heat and they all conduct electricity. So we know that they are metals. They're unreactive. Cobalt and nickel don't react to oxygen. Where we talked about iron, it reacts to oxygen. It will rust. Remember our iron oxide, it oxidizes and it turns into rust, whereas cobalt and nickel do not. All right, if we continue to read this, the figure above shows some of the properties of 3 different elements. The physical properties shown are melting point, electrical and thermal conductivities, and densities. Those are also physical properties. Each element has other physical properties, including color, hardness, and texture. The figure also includes some chemical properties with the reactivity of the element with oxygen in the air. If you had a piece of metal, you could use these properties to determine which element it is. Cobalt, iron, and nickel all look the same. If I set them down in front of you, you would have no idea what they were unless you actually went through and did these experiments on these. Iron has different physical and chemical properties than the other 2 elements. The density of iron is much less than cobalt and nickel, and it also reacts to oxygen and oxidizes. We can also use properties to tell nickel and cobalt apart. They have the same densities and reactivity, but the melting points of these 2 elements differ by 40 degrees Celsius. This property cannot be used, or this property can be used to tell them apart. So let's take a look at our reading and our critical thinking here. Number 4, compare the properties of iron with those of the properties of cobalt and nickel. How do you think cobalt and nickel are used in why do you think they're used in the manufacturing products? Well, do I want to use iron? I mean, what happens when I use iron? It starts to rust, right? I don't want to use iron because it oxidizes with the oxygen. I would want to use cobalt or nickel. So when I'm making my 5-cent piece, my nickel, I'm using nickel because I don't want it to turn all gross and dingy and start to rust. All right, if we take a look down here at a reading check, why can't you use densities or reactivities to determine whether a sample is cobalt or nickel? Well, if I look up here, their densities are exactly the same. They're 8.9 grams per cubic centimeter. Okay, they also conduct electricity and heat. So the only thing that's different between nickel and cobalt, if I were to tell them apart, is their melting points. You can see that their melting points differ by about 40 degrees. Okay, so I could tell the difference between cobalt and nickel apart by setting them up on melting them down and changing them from a solid to a liquid. All right, so that's how we can tell different elements apart, by looking at their physical and chemical properties. All right, the last thing we're going to talk about is how elements can be sorted. Okay, think about all the ways we look at elements. There's all different types of ways we can sort them. In this picture here, we have 3 different dogs. These 3 different dogs are all from the same family. They're terriers. They all have certain characteristics that are like them. We could tell them apart because they're different, but we know that they're very similar, so we think of those as different types of terriers. Think about all the different types of dogs that you have seen. Dogs can be classified based on different properties, their size, the shape of their ears, the length of their coat. You can often determine a dog's breed just by a quick glance. The figure below shows 3 different types of terriers. They're not exactly alike, but they have certain features. So we do the same thing when we talk about elements. The elements can be classified based on properties, just like dogs in the image. There are three major categories of elements: metals, nonmetals, and metalloids. The elements iron, cobalt, and nickel, those are all metals. They conduct electricity. They're shiny. They are similar, but they're not perfectly the same. Okay, they're similar, but they're not perfectly the same. There are characteristics that keep them together. So for example, metals. Metals tend to be shiny solids, except for mercury, which is a shiny liquid. I don't know if you, back in the old days, they'd have thermometers with mercury in there and you'd take it out. You never wanted to do this because if you got it inside, you'd get mercury poisoning and die. But you could go like this and you could move it around and it was really interesting. Maybe ask your parents about that. Maybe they understand it, but that was even almost before my time. Anyway, continuing, metals conduct electricity and heat really well. Non-metals do not conduct heat or electricity very well. Most of non-metals are gases. So gases don't conduct heat and electricity. You're not going to try to run electrical stuff through oxygen. It's just not going to happen. The solid non-metals have a dull appearance. Metalloids have some of the same properties of metals and some of the properties of non-metals. Metalloids are important in electronics because their electrical conductivity can vary with different conditions, so temperatures and pressure and different things like that. Okay, so when we take a look at our reading check here, it says, what are the three main categories for elements? The three main categories that we classify are metals, non-metals, and metalloids. Remember, metals are shiny, conduct electricity. Non-metals are dull, don't pass electricity or heat. And metalloids can do both. Some of them can, some of them can't. It's kind of a combination of both. All right. And number 6, it says, what are some of the physical properties that describe terriers? Well, I don't. Terriers got pointy noses. They got a certain type of coat. They have a different breed. I mean, there's different, it's kind of like metals, metalloids, and non-metals. There's certain things that keep them similar, but there's also things that really separate them. Okay, there's some things that really separate them. So this was our first unit on elements. Hopefully you understand the three pieces. That was one of the objectives that I wanted you to understand, is that there are 3 different types of elements. If we take a look at the periodic chart, it's broken into 3 different parts. And you'll get to this as you get older, and maybe we'll have time to talk about it in this class. But I don't know if we will get 100. We'll get into it too deep. But metals, non-metals, and metalloids. Our periodic chart is made up of those 3 things. Okay, our periodic chart is made up of 3 things. Now that you're done with the lesson, here's what I want you to do. I want you to answer these questions 1 through 5 here, and then we will go over those tomorrow. All right. Hopefully you learned everything from this lesson. I will see you soon.